Hello and welcome to the podcast According to Sci-Faith, where we discuss topics revolving around the compatibility of science and faith. I'm Joshua Göcking and you're listening to According to Sci-Faith. Episode 28, Gravitational Waves. So if we look at electromagnetism, we see electromagnetism is probably one of the forces we first realized to be existent in this world after gravity, to which we will come in a bit. But if we look in the world and we see the electromagnetism going on, for example, when we see lightnings during a thunderstorm, or all these effects that you can experience where electromagnetism is behind it, then people started to, so after they described gravity by Newtonian gravity, they started to describe electromagnetism in physics. So, and once by once, they came to a theory that we know today as the theory of electromagnetism. And at first, it was not completely clear that magnetism and electricity was really connected. There was always a hint of it, and pretty soon it became clear that there has to be some connections, because through an electric field who can stimulate or changes in the electric field, timely changes in an electrical field will always induce a magnetic field, and the other way around, changes in the magnetic field will also induce an electrical field. And this was shown experimentally, and then equations were developed which described this in a theoretical way. And one guy who was able to put all these equations describing electricity and magnetism, one guy who put these equations all together was James Clerk Maxwell, and therefore these equations are called the Maxwell equations, and they describe basically all electromagnetic effects. So what if you have this theory and then you have these Maxwell equations, what you can do then is, so in the first of all, it is like this, that if you basically know from an electrical field is induced by electrical charges. Electrical charges commit an electrical field, so this you know. And a magnetic field, as you might know, does not have sources like or charge these charges, which are basically sources of these fields. But it is still that there are materials like magnets which induce this magnetic field, or an electric field itself by changing in time, which it induces such a magnetic field. So they are induced in some way through charges. Even if you look into ferromagnetism or of a magnet, then you see also there are charges involved in some sense. So electrical charges, or basically the atoms, that electrons in the atoms are basically, for a ferromagnet, are responsible in some sense with their spins for it being a magnet. So, but I won't dive deeper into it. But still, you see that there is something producing these fields, but you also see that they can induce each other. And so instead of using charges, if you solve these equations in one way, you can find a way in which these fields induce each other repeatedly. So basically, you say the electric field is changing by time, and this induces a magnetic field in such a way that this is also changing by time, and again induces an electric field. And this is a wave basically that is produced by this behavior, a wave equation that you can get from these Maxwell equations. And without charges, then you have an electromagnetic wave that is propagating through space. And this could be concluded from Maxwell's equations, and pretty much became clear that one aspect of one of these electromagnetic waves is the wave of the light wave, that they are electromagnetic waves and in a certain spectrum, and this could be described by electromagnetism by then. Before, this was not clear. It was not clear that light was produced by electromagnetism. It was considered to be a separate thing, but when one realized that, one could describe light also by this theory of electromagnetism, which of course made the physics a lot easier, because now you can describe one thing by an already existing theory, so you don't need two theories to describe it, because you now have one thing. So what I want to get on with this is just to describe how in the theory of electromagnetism, this property of electromagnetic waves was discovered, or could be discovered from the theory, and then one realized that we already know this to some degree, but also a lot of other electromagnetic waves were discovered later, be it in the infrared region like radio waves, microwaves, and so on, or in the ultraviolet region like UV light or X-rays or gamma rays and so on. This was all discovered later on, but still there you had this relation to something you already did know. For gravity, this is a little bit different. First of all, from Newtonian gravity, you do not really have this case that you have basically you do not have it in such a way that you would expect gravitational waves or something like this, because this is not part of Newton's equations. This is not in there. This does not follow out of the equations. But since we now know that Newtonian gravity is not the complete theory of gravity, or cannot be the complete theory of gravity, because it cannot describe several findings that we found. For example, the rotation of the perihelion of Mercury. Therefore, Einstein found out that there needs to be another theory that describes gravity, and he found this theory, and this is general relativity. And this he found in 1915, so it's more than 100 years ago that he found this theory. And in this theory, if you use the equations and solve the equations, you already can predict that there has to be something like gravitational waves. And it took really a long time to experimentally confirm those. Actually, it took more than 100 years after this theory was postulated, or rather almost exactly 100 years until this theory could be, or this part of the theory could be experimentally confirmed. Of course, other parts of the theory of general relativity were already confirmed before, but this part took a little bit more than 100 years. So in 2016, the LIGO experiment, which was trying to find those gravitational waves, was in a press release showed that they had found these gravitational waves. And how they did this is pretty ingenious. So what basically happens is what gravitational waves basically are is, so if you look into general relativity, and we had it in some episodes before also, where we were talking about, for example, string theory and so on, and we were talking about what general relativity states, what it states about gravity, and it basically states about gravity that it is the curvature of space-time which leads to gravitational effects. So space being curved basically means that gravitation can occur. Yes. So you can illustrate this like a sheet of a blanket, and you have it stretched out, and then you pull something like a ball or something in the center, and a small marble you let go around, and then it will circle around this ball like the planet circling around the sun. So this is how you can illustrate this general relativity view of gravity. And This means that a gravitational wave is basically a ripple in the space-time. So some ripple some curvature of space-time that ripples through space-time. And this basically means that the distances between places when this gravitational wave passes through this place will change slightly. And this changes really, really slightly. You will not experience it, so it won't be like all of a sudden the car in front of you will be not 1 meter distant from you, but 5 centimeters. That's not what happens. That's not a scale upon which this is happening, because otherwise we would have come up with such a theory much earlier, because we would have experienced it in our everyday life and would have known Newtonian gravity does not describe that, so it cannot be the complete picture. But they are really, really small changes, and therefore the experiments who try to confirm this, that these gravitational waves are really existent, they have to be really, really sensitive to small changes in distance. And the LIGO experiments tried to do this, and they had 2 detectors in different places in the US. And there they had the so-called Michelson-Morley experiment built up. So it's a experimental setup that was already used in Einstein's times, and basically already then showed that there cannot be something like an ether, which they thought before would describe or would be the medium through which light can propagate. And the fact that this could not be confirmed, and that this Michelson-Morley experiment could not confirm the existence of such an ether, led to the development of special relativity, and which basically showed that light does not need a medium to go through space, and therefore special relativity was necessary in order to put relativity into the right order. But this is something for a different episode for some time maybe. But what this basically does, this experiment in this setup as they used it in LIGO, is it creates an interference pattern, or a destructive interference, if the distances that they are measuring remain the same. So I'm not sure if I have talked about interference yet on this podcast, but interference basically is a property that occurs with waves if they interact with each other, or if they interfere with each other, so to speak. And it is the case that they can interfere constructively, then the amplitude will increase, they will add on one another, or destructively, and then they will cancel each other out. And the Michelson-Morley experiment did it such that these light waves would cancel each other out, so they would interfere destructively, unless there would be some minor changes in the distances between the mirrors where they were passing the light back and forth. And if these minor changes were there, then there would be an interference pattern visible. So So before we continue, let's have a short break. And I thought in these breaks I will shortly give you just some insight into my new novel, Alien Thoughts. So if you not have read it yet and you are still trying to think about, do you want to get it, do you want to read it, is it something for you, then I think with these short extracts you will get just some idea whether this book is something for you. So let's start. The Planetary Protection Headquarters was already bustling with activity. Patricia walked quickly to her office. Even though most of her work was done by artificial intelligence machines, there were still enough tasks that required the skills of a human. In addition to maintaining the machines, developing new and better algorithms for the AIs, and finding solutions to processes the huge and ever-growing flood of data, a lot of monitoring activities had to be conducted. The AIs were good at maintaining control without human help, but every now and then problems arose that they were not equipped to handle. That was the job of people like Patricia, who worked in this area. Every day she sifted through the logs of what was happening and what the AIs had no answer for. In the best case, a generic solution was found, which was then implemented in the AIs, further improving them. Patricia focused mainly on monitoring the American territories, also known as rebel territories. When Gerald King tried to prevent the NCD 2000 from going to the market failed and was fired from his company, he founded a movement to politically oppose the introduction of the chip. He set up an office in New York City and tried to achieve independence from the chip technology. This went under the name Negotiations of Independence, or NOI for short. His efforts were in vain, but he found enough supporters who formed a community in Arkansas and resisted the coercion of implanting the NCD 2000. When government pressure became too much, they went into hiding. Since then, nothing has been heard from Gerald King and his followers. But in the years that follows, there were rebel groups in the American provinces. It is suspected that Gerald King led them from the underground. The rebels were familiar with the chip's technology and knew how to minimize its influence. Over time, the rebel movement grew. Eventually, it succeeded in overthrowing the administration of the American province and established a rebel government in its place. Spurred on by this success, they declared war on the New World government under Boris I. A big mistake, as it was soon to prove. In the course of the conflict, many former major cities, such as New York and San Francisco, were completely destroyed. People fled to the countryside began a primitive life as farmers. Many believe that Gerald King died in this war, as he is believed to have been in New York City during its destruction. Boris offered all who submitted to the terms of the planetary government a life of prosperity and left the American provinces to the defeated rebels. These continue to live in pre-industrial conditions to this day, and nothing seemed to change this fact. That's just a short extract. It's about at the beginning of the book when the plot starts to move and it starts to begin. And if you want to find out more, if you are interested in how it will continue, what will happen, what this is really all about, then I really encourage you to get it and to read it. So you can just go to Amazon, type in Alien Thoughts and my name, and then you should surely find it. And if you have already read it, then I really hope that you give a review and this way help other readers to get aware of this product and to know if this would be something for them, and encourage them to get it as well. So thank you for your support. By this experiment, they could resolve really small changes in distances between these mirrors, who were, I think, 2 kilometers or something apart. And with this, they could measure the effects of a gravitational wave, which were coming from the merger of two black holes. Because another thing which complicates the search for gravitational waves is that they just do not occur simply out of nothing. So for electromagnetic waves, it's pretty common that they are produced, that therefore we see a lot of light, which is good, of course. But they can be also technically produced, as you of course know. Also in a radio, they are produced for radio waves, for telecommunication basically. And what you basically just need is a so-called Hertzian dipole. So with a dipole you can create these electromagnetic waves. And this is basically an antenna. It's basically such a dipole. But for gravitational waves, it's not a dipole that it's needed, but a quadrupole. And this makes it a lot harder for them to be produced, and therefore usually only in really highly massive processes like the merger of a black hole or similar things, gravitational waves are produced. And then there's also the fact that they really have small effects on space-time, or are really small in the distances that we hardly can even feel it, or that we cannot feel it, but we hardly even can resolve it. And we really need highly sophisticated experiments like this LIGO experiments to show that they are there. And this experiment is really such sensitive that these distances that the LIGO experiments can resolve are of the order to 10 to the minus 22 meters. And just to illustrate how small this is about a thousandth of the radius of a proton. So it's really, really, really small. And this can be resolved by this. And with this, they could, in 2016, confirm that there are really gravitational waves in our universe. And since then, this is a really promising area of research, because if you know about light, about also the light in the universe, basically astronomy only works with the light that the universe emits. So if you are an astronomer, you look into the sky by using telescopes and similar apparatus, which basically bundle the light that's coming from the sky and make it visible to you, make it more resolved to you, that you can really see what's happening there. Therefore, light is a huge part in resolving what's going on in the universe. But this has also some problems, because as we know now, it's not only light that's coming from there, or there are parts of our universe that do not interact with light, that are not emitting any light. And this is, for example, dark matter, which is just not, as it seems, contributing to the electromagnetic force, and therefore is like invisible to us. And therefore, it is really helpful if there are other ways to look into the sky, other ways to look what's happening in our universe, in the sky, basically, and to get a deeper understanding of our universe. And therefore gravitational waves are really promising in this endeavor, and therefore it's a great area of research right now. And they are deeper looking into this. For example, there's another experiment, and this is called a nanograph, and they have a different approach for resolving gravitational waves. And what they are doing is that they have they basically say, instead of putting our detectors here on Earth, we use basically existing detectors in the universe. So what does this mean? So there are these kind of celestial objects called pulsars, and they are basically rotating neutron stars. And a neutron star is basically a star that has burned out, it's not doing any nuclear fusion anymore, because just there's basically no fuel anymore in it, you can say. And then there's a supernova happening, and as you might know, is then in some cases for really heavy stars, this would result in a black hole in the end, because then the gravitation is the only thing that is there, because due to not doing any nuclear fusion anymore, there's no pressure going against this powerful gravitational forces that are occurring there, and then it will collapse into a black hole. But if the star is not as heavy, if it's a lot less heavy like our sun would be, then it would become something like a white dwarf, how we call it, or if it is a little bit heavier than that, or heavier than that, but still not heavy enough to become a black hole, it will become such a neutron star. And if this neutron star rotates, then it will emit radio waves, basically. And they, when they arrive at us, they look like this star is pulsating, like it has a pulse, and this therefore they are called pulsars. And this is pretty interesting because they behave like a cosmic clock. They are basically, since they are pulsating, it's like a clock. They are basically a cosmic clock. And with these pulsars, this nanograph experiment can therefore build something they call a pulsar timing array, which is basically a huge many clocks in different places in our galaxy, and with this they can basically see where there are changes in this pulsating. So if the pulses of these pulsars should be, of course, constant, they should not change, but if there are minor changes, then this can mean that there are gravitational waves behind this, because gravitational waves, of course, are ripples in the space-time. Therefore also this would yield such changes in these pulses that are arriving us, that are coming towards us from these pulsars. And especially those changes would be correlated. So they to know that this is not just some kind of background or some other effect, you use this whole array or this whole bunch of many pulsars. And since if a gravitational wave passes through, this will not only occur in one pulsar but the other, and they will be correlated. So you will see a correlation or a relationship between them. You can connect them to each other. They are not like randomly occurring. Then you can realize that this has in fact been a gravitational wave. And what this allows, in contrast to the LIGO experiment or to the LIGO experiment, is that it allows to really resolve gravitational waves at much lower frequencies, which would not be possible with an experiment like LIGO. And therefore they could resolve also many low-frequency gravitational waves. And for example, they could also confirm that there are many gravitational waves being produced in such black hole mergers, where before one was thinking, one wasn't unsure how many of these black hole mergers are actually occurring in our universe. But with their measurements, it could be confirmed there are a lot of them happening. And also what they were showing, what was pretty fascinating, is for this, we need to have some background. I was talking before about that up to now, astronomy was basically done by capturing the light that is coming from the stars and the celestial objects. But this is not only the light that is coming directly from the celestial objects, because there was a discovery I think it was in the 50s or in the 60s, where two amateur physicists or amateur astronomists were basically looking into the sky, and they were measuring some electromagnetic waves, and they were thinking this is just some error in their telescope or something that's wrong. There's some bugs on there, and they were realizing that this is not the case, and that this is actually something that they have discovered there. And this is the so-called microwave background, or cosmic microwave background, often abbreviated CMB. And what this is it is believed that this is the remnant of the Big Bang. So during the Big Bang, there was, of course, a lot of radiation emitted by all the processes that were happening there, that were going on there. And the radiation of this is still present in our universe, and this is due to the Doppler shift and different processes. This has actually, just due to the Doppler shift, this has shifted to microwaves, and these microwaves we can measure, and with this we can also resolve not only what's currently happening in our universe, but what was happening in the past. So we can resolve how the Big Bang might have looked like. We can make assumptions about that. We can build models and theories about how this could have looked like, and also confirm our existing theories with this. And what Nanograph found is that there's something similar for gravitational waves, that there is a gravitational wave background, basically, and there are a lot of gravitational waves because gravitational waves would be also during the Big Bang. It is theorized that there would also be gravitational waves be produced in the processes there, and therefore these gravitational waves, it is believed that they are still present, and that, like the microwave background, they are in this gravitational wave background. And by measuring those, we can also make more measurements about what was happening when the structures were formed, what was happening during the Big Bang, and so on. And so there's a lot of promising facts that show that there are really promising results that can be achieved by looking deeper into gravitational waves, by resolving them more accurately, and get more insights into how these are shaped, and how how many of them are present at which frequencies, at which properties do they have, and therefore this is a pretty exciting area of cosmology and of physics. And therefore this experiment, or these results that they were presented last year, 2023, and many say that this was one of the most exciting, or the most promising, or one of the greatest results that came out of physics in this year. So I think this can also be interpreted in the spirit, and I think this can also shown to be mean. So those are waves that are present in our universe, like the microwave background, but also this gravitational wave background. And I think the Bible tells us that God holds the world together by His word, and I think that these waves being everywhere in this universe, spreading through the universe, are a symbol or a sign for His word that is passing also through this world, and holding it together, holding it in place, and holding everything together. And also it shows, if you imagine, so if you think of it, that while this light, this electromagnetic light, is basically, we could see it if we could see microwaves, but we can easily detect them, and this is basically easily to see, like the astronomers who look in the sky and see all this light that is going on there. But there is still some layer behind it. There are these gravitational waves which we could not see, which we cannot actually resolve with simple measures. I mean, we can resolve it by now by the highly sophisticated techniques we have, but it's a lot more hidden. And I think this is also a sign that something that sometimes the things of God are more hidden. They are not really directly accessible to us, and that we have to put some effort in to find them. Not effort in a sense of works of the flesh. That's of course not what I'm talking about, but I think the Bible always talks also about an endeavor that we take to uncover His mysteries, that it's not just that He lays it all out before us, but we need to uncover it. We need to have a passion and a urge or a hunger for more of Him, to really experience Him, to see more. And then, as with the gravitational waves, where we can find out a lot more about the universe that we did not know before, as it is in this case, we can, with God, if we really dig deeper and go deeper into what His word says and what He reveals to us, we can understand a lot more. We can get to know Him a lot deeper and understand a lot more things, but we need to be willing to dig deeper, to allow His mysteries to be unveiled in front of our eyes. And I think this is really what He's calling us for, to come closer to Him and to dig deeper into His mysteries, that He can show us what He's thinking about us, how He sees us, and what He has planned for us. So that's everything for today's episode. I hope you liked it and you enjoyed each part of it. If you want to get in touch with me or discuss a topic or want to give me some feedback, then feel free to contact me using the contact form on my website, sci-faith.de/en. And there you can go to the contact tab and contact me. And if you have any other things or episodes you want to have covered there, or topics you want to have covered, feel free to contact me there. Also, if you are not yet familiar with the format in which this podcast is produced, let me just briefly explain it to you. So there always at the beginning of a month or of a block, there is a big block of 4 episodes in one thing. It's kind of like a preview, which I call it, where you have the next 4 episodes all in one episode together, combined. And this is for people who like to hear long format podcasts, who have a long way to work or something else, where they can listen to a long episode and can then have a preview of the next 4 episodes all at once, and are completely up to date from the beginning of the block. For those who like their episodes shorter, who prefer it if they have a half an hour or even less of a podcast episode, for those there is every week afterwards will appear a podcast episode almost in that length, and this way I can publish every week a new podcast every episode, and everyone can have it his own way, either once a month a long chunk of content, or once a week a shorter format podcast episode. So I think that's the best way for everyone, and also for me when I'm producing it. Please also note that this is an independent podcast, which means that it is recorded, produced, and marketed by me. So I really need your support in this. So if you like this podcast, then give it a 5-star rating. And if you have the time, even write a review to it. This just helps other listeners to become aware of this podcast, and then people who might be interested in this content can become aware of it. Also, if you have friends who you think would like this content, then recommend it to them and share it with them. Also, you can support me in other ways, for example by reading my blog and subscribing to my newsletter, or even by reading my books, which you can find on Amazon. For example, there is my latest novel out now is Alien Thoughts, which is pretty entertaining from the feedback that I gotten, and so it's also in some way related to science and faith. The topic of it is also in there, but of course you can also read the book to this podcast, Sci-Faith, The Compatibility of Science and Faith, which is also available in English since last year. Thank you for that, and now I wish you a wonderful day, and I'm looking forward for you to tune in again next time.